Hi everyone. Today our lesson is about unit rate and using that as a foundation for slope and rate of change. So slope and rate of change are our 8th grade standard, but we need to be able to understand unit rate in order to understand slope and rate of change. Here's your do now. Go ahead and pause the video and solve these two problems. Now that you have them solved, let's go ahead and solve. If you went to the store and bought 5 cookies that cost a total of $1.25, what is the price per cookie? So I know that I can use tape diagrams, I can use pictures to help me solve. So I'm going to go ahead and draw out my 5 cookies, and I know that the total of these cookies was $1.25. So if I have to take this $1.25 and split it evenly between my 5 cookies, I know that splitting evenly is division. So I'm going to take my $1.25 and I'm going to divide it by my 5 cookies to get that each cookie is 25 cents, or 25 cents per one cookie. So this is our unit rate here because it's per one cookie. Now, if I have the same price, how much are 6 cookies? Now, if I know that each cookie costs 25 cents, I can multiply that by the number of cookies that I have and get my total, which would be $1.50. So this is how we find unit rate. We find unit rate by dividing, and then we can use unit rate to solve for other values. So today our lesson is building up to 8.EE.B.5, which is our standard. If you are confused by what I say in here or want to look up other problems, you can search this standard in Google, and that'll help you with other videos, with other problems that you can try to practice. Our objective for today, I can find and compare unit rates in proportional relationships in word problems, like the one in the middle, in tables, like this one on the left, and graphs, like the one on the right. So these are all the same problem, they just are in different forms. It's the same problem from the do now, again, just in a table, word problem, and graph. Our first problem for today is about a road trip. So this is my picture of a Jeep. You're driving this Jeep, you have some friends, you have some snacks, and we're going on a road trip. On your road trip, you're driving for 4 hours before you have to stop. If you drove at a constant rate the whole time, meaning you're driving at the same speed the whole time, and you drive for a total of 260 miles, the question is how many miles, so that's what we don't know, we're going to drive in 1 hour. So first, think about how you would solve this. Again, I know that I can use tape diagrams or pictures to help me solve. So I'm looking for how much is in 1 hour. So this box represents our 1 hour. But I didn't drive just 1 hour, I drove 4 hours. So each of these boxes should be the same. And the total that we drove here was 260 miles. And I'm going to go back and I'm going to label this as 4 hours. Just so I remember that the green boxes represent my 4 hours. So again, if I know my total is 260 miles, and I'm looking for how much 1 hour is, and I have a total of 4 hours, I can divide those to find my unit rate. So this is what the math looks like. So 260 miles divided by my 4 hours is going to be equal to, when I divide this, I'm going to get 65 miles. So it's 65 miles per 1 hour. So another way we could show it is we've done equivalent fractions where we divide the denominator and the numerator by the same number. So that's what we did here to get our simplified fraction. And now, when we simplify that fraction, 65 divided by 1 hour would be 65. And when we label that, our time here would be 65 miles per hour. So that's how many miles, to answer this question, 65 miles in 1 hour. After we answer questions, we always want to ask ourselves, does this answer make sense? If we go back 65 miles per hour, if we're going on a road trip, that would make sense. That's about a speed that you would be driving. So always asking yourself this question as you work through problems. Our next example is about cookies and sugar. So Miss Oliver is making cookies for our class. The table below shows how much sugar she needs for a specific amount of cookies. So if she wants to make 100 cookies, she needs 8 cups of sugar. So we're going to use this table to figure out how much sugar she needs for one cookie, for each cookie. So if this is what one student did, let's look and see if this answers our question. So what they did was they put 25 cookies divided by 2 cups. I agree with that fraction because they're using the x and the y value that are related to each other. They simplified it to get 12.5 cookies per 1 cup. Okay, think about whether you agree or disagree with that. I do agree with what they did here. This looks like correct work. Let's go back and see if they answer the correct question. So the question is, how much sugar is in each cookie? Well, what I have here is the amount of cookies for 1 cup of sugar. That still doesn't tell me how much sugar is in each cookie. It looks like what this person did, a lot of us fall into the trap of thinking we always have to put the bigger number on top when we're dividing, or we have to divide the bigger number first. That is not always true. So this person tried to do that. They did find a unit rate, but it's not the one we're looking for when we're looking for the amount of sugar in each cookie. This tells us how many cookies from 1 cup of sugar, but that's not the unit rate we're looking for. So this is not the answer we're looking for, so let's see if we can find a student who did it correct. So this is what another student did. Again, they still used the 2 and the 25, which is great. But instead, they switched it. They inverted the fraction. They put the 2 cups on top and the 25 cookies on the bottom. I agree with this because we are looking for per 1 cookie, and that's what we have as our denominator here, 1 cookie. That's what we want. And you'll notice, hopefully, that the denominator is cookies on the left side and the denominator is cookies on the right side. So we want to keep the denominator the same label as we're doing these unit rates. Cups are both on top, cookies are both on the bottom. And whatever you're looking for is going to be the the denominator, because you're looking for 1 cookie, so we need 1 cookie on the bottom. So here our answer is not a whole number, which is completely fine. The answer then for how much sugar is in 1 cookie would be 0 8/100 cups of sugar in each cookie. So that would be our unit rate. So each cookie you eat has that much sugar in it. Our last example quickly is YouTube. The graph shows the amount of views Hadafa had on his YouTube in minutes. Use the graph to find the number of views he had per minute. So in this one, we're finding per minute. We just said that per minute, whenever we're finding that has to be our denominator. So we know that our denominator is going to be minutes. So I have my denominator as 5 minutes. That means, according to this red point here, at 5 minutes, the views was 175. So 175 views divided by 5 minutes would be 35 views per 1 minute, which means my unit rate would be 35. So then my rate here is 35 views per 1 minute. So each minute that passes, there's 35 views on his YouTube page. And hopefully what we're noticing too is we're always taking the y value and dividing it by our x value to find the unit rate. It's always going to be y divided by x in all of the problems that we've looked at. So in the table, x and y is still the numerator, x is still the denominator. Same with our word problem. If this was in a graph or a table, it would be y divided by x. So how do we find unit rate, everybody? Good, y divided by x. So these are things to remember as you move into your practice. Unit rate is per 1 unit. We find unit rate by dividing, and we divide y divided by x. Y divided by x. We can use unit rates to compare, which is what we're going to do in our practice. And lastly, we need to remember that unit rate, rate of change, and slope are all the same. They are just called different things. So here are your 4 practice problems. They are about my siblings. So Kyle is a construction worker, my older brother. My younger brother, Kevin, is a landscape worker. And my oldest sister, Angela, she is a counselor at a school. So these are my real siblings. Their the money is made up, the amount of money they make is made up, but the jobs they do are accurate. So go ahead and figure out these 4 problems, and we'll check back when you're finished. Go ahead and pause the video. Now that you've had time to practice these, let's go ahead and solve. So we have Kyle works 80 hours and he makes $4,000. So how much does he make? How much money per hour? So what we know is he works for 80 hours. So in our do now, we drew out 5 cookies. So I could draw out 80 hours, but I don't want to draw out 80 boxes. So I'm just going to draw some boxes and then label it 80 hours. And I know that in all of those hours, he makes $4,000. So again, I know that I'm going to divide my 4,000 divided by my 80 hours. And when I simplify that, when I divide 4,000 divided by 80 hours, I'm going to get $50 per 1 hour, meaning that my unit rate here is 50, or the slope if I had a line would be 50, and it's increasing by 50, so it's positive. So he's making $50 per hour. Then we have Kevin, and I use this first red dot here, which would be 2, 144. So that's where I got my values for my fraction right here, $144 for 2 hours. So when we divide 144 divided by 2, I'm going to get $72 per 1 hour. So then our unit rate here would be 72. So he's making $72 per hour. Lastly, my sister, Angela. Remember, we're always dividing our y divided by x. So my x values here are blue. My y values are green. So I can take either the 202 divided by 8, or I could take the 101 divided by 4. Either way, I should get the same answer. And I did. When I divide both of these, 202 divided by 8, I get 25 and 25 hundredths. When I divide 101 divided by 4, I still get 25 and 25 hundredths, meaning that Angela makes $25.25 per hour. So that is her rate. The last question then, which person has the greatest unit rate or greatest rate of change, and what does that mean in context? So we know Kyle had 50, Kevin had 72, and Angela had 25 and 25 cents, which means Kevin had the greatest rate of change. So Kevin had the greatest rate of change, which means that he makes the most money per hour. So if we just look here at, here, it's really hard to tell who makes the most money because it's not in a unit rate. But we use unit rate to compare. So now that we've found that they're all per 1 hour, we can compare them really easily. That's why we use unit rate. So really great job. Go ahead and star the ones you got correct on your paper, and then fix the ones that you didn't get yet to make sure you understand them. Before I give you your con assignments, just remembering unit rate is per 1 unit. We find unit rate by dividing y divided by x. We can use unit rate to compare like we did with my siblings to see which one makes the most money per hour. And lastly, remembering that unit rate, rate of change, and slope are all the same, they're just called different things. In your Khan Academy assignments, another synonym for all of these words is constant of proportionality. So again, all of these words are synonyms, they're all the same. People are just going to use them they're going to use them at different times. So don't get confused by all those different words meaning the same thing. Here are your 4 practice assignments in Khan Academy. 4 looks like a lot. These should go pretty quick. Unit rates, constant of proportionality from graphs, in tables, and comparing them. You got this. Let us see what you know.